All right, I want to do a quick video to explain how I have my coolant system set up on this car. It's definitely very different from factory, a little unconventional for a Subaru, but truthfully more in line with the way most vehicles actually work in terms of how the cooling system works. Subaru has a very bizarre design where essentially in factory form, they have a turbo, what they call a turbo coolant reservoir that kind of lives over in this area. And its purpose is mainly to be two things. One, it kind of serves as a high bleed point since the turbocharger normally sits higher than the radiator on a Subaru. And the other thing is it kind of allows a place for the coolant to work its way through the turbo when you shut the car off, sort of acting like a turbo, cool down reservoir, which is where it gets the name. But it's kind of a poor design because it doesn't actually, the Subarus don't actually have a proper coolant expansion tank. In other words, somewhere for the coolant level to rise into with a nice air gap that's maintained. Instead, what they do is they run two radiator caps, a one-way and a two-way, and essentially as the coolant expands and doesn't have anywhere to go, it pushes out the radiator cap into a reservoir that normally lives in this area. That pushes out through a straw and it basically fills that reservoir up. So when you're setting your coolant level, you set that in the reservoir, low when it's cold, high when it's hot. The problem with that design is a couple of things. One, if you're running the car really hard, such as on the track or doing some spirited driving, the coolant expands, the coolant gets hot, expands, and pushes over into that reservoir. It's also possible for air gases to push into there as well and kind of overfill the system. Then the problem is, as the car cools back down, it has to draw that coolant back in to take the place of the contracting coolant, if you will. But the problem is it doesn't always do that so well, and it's easy to get air introduced into the system. And air in your coolant system makes it not work very well, of course. So the better solution, and the way that most other vehicles work, is using a coolant expansion tank. So what I've done here is converted my car to work with a coolant expansion tank. I'm using the Radium Universal expansion tank mounted here on the firewall at a pretty high point. The higher the better. So now this serves as my high point for bleeding the system and topping off coolant. And essentially over here, this is just a sealed cap. This doesn't release any pressure, and the normal nipple right here has been blocked off with a plug. So when I'm filling the system up, I can fill the radiator first full to here, and then what I do is I put my funnel here on this, and I fill this up, and I can burp it from here. I don't actually even have to put a funnel on there. Truthfully, what I do is I just fill the coolant level low in there, and I run the car with the cap off, and this acts as a burping funnel, essentially. Once I have my coolant level set, which is at the low mark here when cold, about 1/3 of the container, I put the cap back on and I run the system. At that point, everything stays sealed, and as the coolant heats up and expands, it comes up the sight tube here, but doesn't completely ever fill this up. You don't want to fill this up. You want a space for the air to separate from the coolant. And that's essentially what's happening here. As the coolant comes out of the head, it goes through the turbocharger like it normally would. But rather than running to the coolant expansion tank, it runs up to the top of this where there's air. That allows the coolant to separate from the air and go down to the bottom. And then the bottom connects back to the hard lines that go down to the back of the water pump. So that kind of serves to help warm the engine up and also help separate the air from the coolant and keep everything clean. The other part of this reservoir, they're connected with a kind of a small passageway, is again the reservoir where the rest of the coolant sits. At the bottom of this side, that connects back to this hose here, which balances it back to the radiator. So essentially, as the radiator gets warm and the coolant gets warm, it expands, and that hose allows it to expand up into this tank and again allows all the air to separate. So this is the only radiator cap in the system, a 1.5 bar cap. As long as the air pressure or coolant pressure doesn't exceed 1.5 bar, nothing comes out of this nipple. If my coolant pressure does get high enough and it's just air, the air can escape from here, no problem. If for some reason, so let's say it's pushing coolant or having a major issue, first of all, the coolant pressure sensor that I've got here is going to indicate that, shut the engine down. But in case that happens very, very quickly, essentially this would act as a blow off for the coolant, and you'd see a ton of coolant steam coming off of here, but normally that would never happen. So that's the way the system works on this car, and what I've noticed as a result is much better cooling on the track, much less issues with temperature fluctuation, and coolant pressure readings are extremely steady, meaning that as the car warms up, it reaches a coolant pressure value that kind of settles in based on coolant temperature. And as you're pushing the car hard on the track, the coolant pressure rises with temperature in a pretty consistent ratio. So that makes it a lot easier to monitor, to measure, and to know what's going on with the cooling system. So hopefully this video is helpful to understand how we've done this cooling system, why we've done it this way, and to let you guys know that it works very well.